Okay, for this question, we have three resistors in series connected to the 12-volt source labeled E. For the first part, we want to calculate the total resistance of the circuit. Remember, the rules for series circuits applies to this circuit. The total resistance, RT, equals the sum R1 plus R2 plus R3. That gives us 1 ohm plus 2 ohms plus 3 ohms for a total resistance of 6 ohms. Part B asks us to calculate the circuit current. We will apply Ohm's law to the circuit, whereby the Ohm's law says the current in the circuit, IT, will be equal to the total voltage applied to the circuit, which is E, divided by the total resistance of the circuit. That gives us 12 volts divided by 6 ohms, or a total current in the circuit of 2 amps. Now, in part C, we are asked to calculate the voltage drop across each resistor. We will now apply Ohm's law individually to each resistor. Well, if we write Ohm's law for voltage, we have V equals I times R. Remember that in a series circuit, each resistor has the same current through it. So I1 equals I2 equals I3 equals 2 amps. So if we apply Ohm's law to resistor 1, we get V1 equals I times R1. We have 2 amps multiplied by 1 ohm, and that gives us a voltage drop of 2 volts across V1. If we continue, we apply Ohm's law to resistor 2, V2 equals I times R2. That gives us 2 amps multiplied by 2 ohms, or 4 volts across V2. Likewise, for V3, we have 2 amps multiplied by 3 ohms, for a total of 6 volts across R3. Now, if we take the sum of these voltages, V1, V2, and V3, we'll find that 12 volts equals E. That verifies that KVL applies to this circuit. Okay, now for part D, we take a bit of a different approach to this circuit. It tells us to use KVL to determine the current in the circuit. Now, if we ignore the calculations we've just done and we look at the circuit, if we write KVL around the loop, remember we can start in the lower left hand corner, go clockwise around the loop, include a term for each component. We have the source, which is a voltage rise. We have 3 resistors, which are loads or voltage drops. So when we write KVL, we'll say that we have plus E, subtract V1, subtract V2, subtract V3. This completes the loop. KVL says that sum is equal to 0. Now, the next thing we want to do is say that V1 equals I times R1. V2 equals I times R2. V3 equals I times R3. So, we have V1 plus V2 plus V3 equals 12 volts, whereby if we switch the voltages across the equal sign and change their sign, we can write this equation that we have here. Now, we have I times R1 plus I times R2 plus I times R3 equals 12. We know that we have 1 for R1 plus 2 for R2 plus 2 times I for R2 plus 3 times I equals 12. Now on the left side of this equation we have 6I equals 12. If we bring the 6 to the denominator on the right side, we have I equals 12 over 6 equals 2 amps. And that gives us the current in the circuit using KVL. Now, the reason why that's helpful is we've applied a bit of algebra to the circuit, and it allows us to find the current in the circuit without having to go through the total resistance and so on. Well, it seems a little more complicated, but it shows how KVL may be useful applied to this particular circuit.